Last episode you installed OpenFOAM and ran your first case, the cavity, without understanding a single file. Today we fix that. Today we open that folder and name every single part, so you can read any case anyone hands you. Every OpenFOAM case has the same 3 folders. Learn these once and every case looks familiar. 0 is where the solution starts. Constant holds things that don't change during the run. System controls how the run happens. Let's take them one at a time. Before the folders, one thing they all share. Every OpenFOAM file is written in the same format, a dictionary. It looks like this. A keyword, then a value, then a semicolon. Curly braces group related keywords into a subdictionary. Every file begins with this FOAM file header. It tells OpenFOAM what kind of data is inside here, a vector field called u, the velocity. The 0 folder. Its name is the start time, time equals 0. Inside are your field variables, velocity, pressure, and so on. 2 parts matter. Internal field is the starting value everywhere inside the domain. Boundary field sets what happens at each patch of the boundary. Here the moving wall is driven at 1 meter per second, a fixed value. The other walls use no-slip, the fluid sticks to them. This is the lid-driven cavity you ran last episode. And that dimensions line? It's OpenFOAM's superpower. Every field carries its units, and the solver refuses to add quantities whose dimensions don't match. Bugs caught for free. The constant folder holds what stays fixed through the whole run, the mesh, and the fluid's physical properties. Polymesh is the geometry, a list of points, the faces joining them, and the cells they enclose. This is what block mesh or snappy hex mesh writes for you. And transport properties holds fluid constants, here the kinematic viscosity, nu. Notice it too carries dimensions. Last folder, system. This is the control room. 3 files run the show. controlDict sets the clock, when to start, when to stop, the size of each time step, and how often results are written to disk. fvSchemes is where the finite volume method lives. It picks how each derivative in the equations is turned into arithmetic. We'll spend all of phase 1 right here. And fvSolution chooses the linear solver and its tolerances, how the giant matrix gets solved each step. Phase 3 digs into this one. That's the whole anatomy. 0, where the solution starts. Constant, the mesh and fluid properties. System, how the run is controlled. You've seen that the mesh lives in constant. Next episode we build one ourselves with block mesh, hex blocks, vertices, grading, and then deliberately break it to see what matters. See you there. Last episode